कैसे हो सभी लोग? So let us today I'm back again with a video on binomial theorem, and this will be the lecture 4 of the binomial theorem. And in last lecture we studied about the NGT, that is the numerically greatest term of any binomial expansion. So let us move forward and take the continuation of the topics, and today's topic will basically the discussion on the properties of binomial coefficient. So the properties of binomial coefficient. Now we already saw that the number that is basically written as NCR is known as the binomial coefficient. So there are a lot of properties involving that particular number of NCR, and in question the mostly types of question that will be coming in the examination will basically form that on the based on the concept of binomial coefficient, there is a sum or maybe the product of the binomial coefficient, because this is the portion where it is the most nice or the tricky questions are actually made. Okay, so if I firstly see that we already know that in binomial theorem, what we see that 1 plus x raised to the power n can be written as nc0 plus nc1x. Now just remember this particular type of expansion, nc2 x square and so on up to ncn x to the power n. Okay, so this is the basically a simple binomial expansion. So where nc0, nc1, nc2 are all binomial coefficient of various power. Okay, these coefficients are also known as binomial coefficient in this particular problem. In this particular case, our binomial coefficient of various powers of x, okay, are known as coefficient of various powers of x. Okay, x also called binomial coefficient. Also, you can say this as binomial coefficient. Okay, because there are no other terms involving this particular this C factor, that means the combinatorial coefficient factor. Okay, so the very first thing that must come into your mind, that what will be the sum of all these particular binomial coefficient. So if I sum up this nc0 plus nc1 plus nc2 plus up to ncn, what will be the value, and how we basically calculate the sum of all the binomial coefficient of any given number. Okay, आपके पास कहीं भी एक्सपेंशन दिया रहेगा कि यू हैव टू फाइंड फॉर द x प्लस वाई होल रेज़ टू द पावर n, उसका उस बाइनोमियल एक्सपेंशन का बाइनोमियल कोएफिशिएंट का सम निकालो. सो यू बेसिकली नीड टू डू द स्टेप इज दैट पुट द वेरिएबल्स, ओके, पुट द वेरिएबल्स value to 1. Okay, now if you put the variable value equal to 1, you will get the value of sum of all coefficient, or I mean to say sum of all binomial coefficient. Okay, the sum of all binomial coefficient in any particular expansion or binomial expansion is basically obtained by putting the variable term as equal to basically 1. So from here, if I look at the product, the sum, sorry, nc1 plus nc0 plus nc2 and so on up to ncn, this value will become that if you put the value of x is equal to 1, so this will become 2 raised to the power n. Okay, so this is the basically sum of all the binomial coefficient. I hope this particular thing is clear. All right, now similarly, if we put instead of x is equal to 1, we put x is equal to -1, then you basically get change or interchange like alternatively plus and minus sign. That means if I have to find the summation of nc0 minus nc1 plus nc2 and so on up to -1 raised to the power n ncn, this will become equal to 0. That means you are getting alternative minus and plus sign, and this particular alternative minus and plus sign is basically because of this concept, that is -1 raised to the power something odd is equal to minus, and -1 raised to the power even is equal to even number, I mean equal to 1. Okay, that means a positive number. Okay, so this is how basically get to the value of the sum of the binomial coefficient and the sum of binomial coefficient with alternative plus minus sign, that is equal to 0. These both results will come very handy in lot of questions of probability, in questions of set theory. Okay, so you must know how to use these particular questions. Okay, let us move further and let us see another important thing, that is basically whenever we are basically given with the sum, something like this, like sum of all the even binomial coefficient, that means even, I mean to say that the value of the lower suffix is even, then we basically find this by okay, so if n is equal to even, so you have to find the sum of this particular value. So this comes out as equal to 2 to the power n minus 1, and this particular result is also true for nc1 plus nc3 and so on up to for the odd numbers. Okay, and so on for the odd numbers. Now how this particular result is coming, so if you look at nc0 plus nc1 and so on up to ncn is equal to 2 to the power n, and similarly nc0 minus nc1 and so on up to -1 whole raised to the power n ncn is equal to 0. Now on adding both the terms, you will get 2 times of all the even numbers. Okay, now the even terms will survive, and this particular will be equal to 2 to the power n, and if I cancel 2 on this particular side, this will become 2 to the power n minus 1. That means the sum of all the even numbers, I mean the even lower coefficient numbers, will binomial coefficient is equal to 2 to the power n minus 1. And similarly the result goes also, if we instead of adding this both the equations, okay, this is equation number 1, this is equation number 2, instead of adding this both the equation, if we subtract the both the equation, we will also get the same result, which is pertaining to this particular value, is pertaining to this particular result. I hope this particular thing is clear. Okay, so the sum of the lower even suffix of the binomial coefficient is equal to the sum of the binomial coefficient with lower suffix as odd, and is equal to, value is equal to 2 to the power n minus 1. Okay, so I hope you will remember this particular result. Now let us look the fourth property, and that is basically NCR is equal to, we have already done this particular thing, that is equal to n by r into n minus 1 c r minus 1. Okay, and this can also be written as n minus 1 into n divided by r into r minus 1 into n minus 2 c r minus 2, and so on. We can also express this particular number as a recursive form. Okay, as a recursive form. This is basically due to the factorial notation. Okay, I hope this thing is clear. Okay, now this will come also very handy when you solve questions on binomial expansion, which will involve the products, the summation. Okay, without the use of differential. Okay, now but we will see that in very important types of question, we have to basically use the differential concept, so that to get to the binomial summation. Okay, sum of the binomial coefficient, that is basically easy method. Okay, but in some cases it is basically feasible to solve it by using this particular concept. Now let's move further, and if I look at the fifth property, this property talks about the sum of the product of coefficient of the sum of the product of the coefficient of this particular binomial expansion is basically is given by in place of x we just replace it by 1 by x. Okay, in place of x we just replace it by 1 by x, and in that situation, if I have to get it for the sum of the product of the binomial coefficient, sum of the product of binomial coefficient, that means basically you need to firstly get 1 plus x की power n, इसका जो expansion है हमको पता है, ठीक है. So from there, if I, and also in place of, if I have to get to the product of the coefficient, then in basically in place of x you have to replace it by 1 by x whole to the power n, and this will give me nc0 plus nc1 1 by x. Okay, and so on up to ncn 1 by x raised to the power n. Okay, and this particular will be the result. Now what I want to do is basically cross multiply or take the product of this particular two terms. So if I take the product, okay, so if I take this two product, then I will get that result as this particular result. So if I take the product of the corresponding terms, then this will become nc0 whole square plus nc1 whole square, and so on up to ncn whole square. And this result is nothing but, if we look at this particular, is a sum of the square of binomial coefficient, or I mean to say the product. Okay, and similarly there will be other terms involving the product. Okay, I am not writing the product terms. Okay, so you can see that the product of all the binomial coefficient, that means nc0 whole square plus nc0 nc1 plus nc0 nc2, and so on, there will be a lot of terms involving in it, but this particular result is just simply given out by this particular product, and that is basically 1 plus x raised to the power n whole divided into, I mean to say this, if you take the if you solve this fraction, this will be 1 plus x to the power 2n divided by x to the power n. So if you solve this, you will basically get to the sum of the product. Okay, sum of the product, sum of product of binomial coefficient. Okay, so in place of, if we, and then we can basically solve by this particular expansion, and in this expansion we have to look for which coefficient. Now this particular types of question I will take up in lot detail. Okay, now in this particular type of question, in many a time the question will ask only for the summation of this particular result. Okay, only of this square of the binomial coefficient. Okay, so in this particular case you have to look for which particular coefficient of x will basically give you the desired result, That means whenever you're multiplying, you're basically getting some coefficient of x. Now this particular term is basically generated when the coefficient of x is equal to 0. When the coefficient of x is equal to 0, that means x raised to the power 0. I mean to say that. Okay, I'm sorry for that. X is equal to 0. I mean to say that x ki power is 0. Okay, and similarly there will be other terms which involve the terms where there will be the coefficient of x. Okay, but in that situation, when we have to calculate for the square of the values, then we basically calculate it out by taking out the coefficient of this particular number. So whatever, okay, so what I mean to say is that whatever sum of the product of the binomial coefficient is desired from this particular result is basically calculated by taking the coefficient of x raised to the power r from this particular expansion of this particular thing, 1 plus x raised to the power 2n into x raised to the power minus n. So from this particular expansion, if you calculate for the x raised to the power r, you will basically get the various different product of the sum of the binomial coefficient. I hope this thing is clear. So in this particular scenario, if you want to look at what will be the sum of C0 CR plus C1 CR minus 1 and so on up to CR into C0. So this particular result will basically be obtained by taking coefficient of x raised to the power r in that particular result, that is 1 plus x to the power 2n into x raised to the power minus n. So from here, if I have to take for the coefficient of x raised to the power r, I'll get this particular result as 2n c n plus r. Okay, 2n c n plus r. I hope this particular thing is clear. Okay, this is just by taking the comparing the coefficient and by taking the coefficient from this particular form. Okay, so if I do this, so you can do this particular by yourself also. So you can write this nc 2ncr x to the power, this will become r, and from this particular thing, that is x to the power n, so this will become r minus n, and you have to look for the value of this is equal to r. So in place of r, you replace by r dash, so the r dash value is equal to r plus n, and that will make this particular coefficient as 2n c n plus r, and that is basically the sum of this particular values. Okay, I hope this particular result is clear. So in order to get to the sum of the product of the binomial coefficient, you just have to replace, in place of x, you just replace it by 1 by x and take that product, and in that product calculate for the coefficient of x to the power r in order to get to the desired result. So from here, the important result that you must remember is basically nc0 whole square plus nc1 whole square and so on up to ncn whole square, and this value is basically equal to by taking out the coefficient of x to the power 0. I mean to say x to the power 0 coefficient. So from here, if I look for x to the power 0, that means basically the r dash will become to n, and this result is equal to 2n cn. So you have to directly remember this particular result. This particular result comes very handy in problem solving. Okay. So I hope this particular thing is clear. Now let us move further and let us talk about the seventh property. Okay, the seventh property, that is basically is equal to NCR. Now there will be many questions involving this particular concept, that is NCR plus NCR plus 1. Okay, sorry, NCR, or you can write this also. Okay, NCR plus NCR plus 1. Also, you can write this as NCR plus NCR minus 1. Okay, this particular value will be equal to n plus 1 CR. Okay, n plus 1 CR. Okay, you just have to remember this particular value. Okay. Now this comes very handy in question solving. Okay, many times there will be questions regarding this. So let us take some few examples to illustrate what we have studied so far. Now let me add one pages. Okay. Okay, let us take some example. Okay, so what is the question that is asked? We have to basically find out the summation of C1 by 2 plus C2 by 4, sorry, C3 by 4. Okay, the question says as C1 by 2 plus C3 by 4 plus, of course, if nothing is written, this will basically be assumed as n. Okay, NC1 by 2, NC3 by 2, NC5 by 6, and so on. This particular summation, you have to calculate for this particular summation. Okay, so what is the value of this particular summation? So if you look at how to solve this particular question, okay, so what trick can we apply for doing this particular question solving? What we can see that this NC1 can be written as n divided by 2, and this NC3 can be written as n into n minus 1 into n minus 2 whole by 3 factorial, that is 6, and there is 3 factorial into 4, that will become 4 factorial. And similarly, this particular term can be written as n into n minus 1 into n minus 2 into n minus 3 into n minus 4, that is 5 terms, and divided by 6 into 5 factorial, that will basically become 6 factorial, and so on. Okay, so from here what I want to do, okay, so from here what I can do is basically multiply as well as divide by n plus 1. Now why I am doing this, you will basically understand in the next step, is basically as, so 2 can be written as 2 factorial. So by multiplying and dividing by n plus 1, I can write this as n into n plus 1 divided by 2 factorial, plus this can be written as n into n plus 1, okay, n plus 1 into n into n minus 1 into n minus 2 divided by 4 factorial and so on. Okay. So from this particular result, what we can see and what idea we basically get it as this thing, that is NC. Okay, this particular result of n into n, so this particular thing will basically be obtained as, so if you look at this particular term, this will become 1 by n plus 1 whole raised to the power. So if you see this particular thing, so what we can look this particular term as, so in place of, just by listen to me what I'm saying, in place of n, think it is put as n plus 1. Okay, so what we can get this particular result, it has 2 raised to the power n plus 1 minus 1, okay, minus 1 and minus of 1, because we are missing that first case. Okay, now this particular number can be simultaneously drawn like that. Okay, that means what I try to do is basically n minus 1 factorial and divided by the remaining part. So what I basically get, that is n plus 1 into n divided by 2 factorial. Okay, so this is nothing but the n plus 1 C2. Okay, similarly this is nothing but n plus 1 C, this is nothing but n plus 1 C4. Okay, so from here this particular terms will resembles the summation of such a number, which basically implies, that is in place of n, that is n plus 1. And if you are looking for the sum of all the values when the coefficient has the lower suffixes even, we already see that the result is basically 2 to the power n minus 1, and in place of n we have to just put n plus 1. So what will the result will become, that is 2 raised to the power n plus 1 minus of 1. And since the first term is missing, that is the n plus 1 C0 term is missing, so what we'll do, we'll firstly add that particular term as well as subtract that particular term. So n plus 1 C0 is nothing but 1, so we have subtracted that particular term, and this will become 2 raised to the power n minus 1 whole divided by n plus 1. Okay, so this is a very important type of question. So the answer to this particular problem is basically equal to, the answer to this particular problem is equal to 2 raised to the power n minus of 1 divided by n plus 1 divided by n plus 1. I hope this particular result is clear. Okay, very important type question. How do we get this particular problem, that कि n plus 1 से divide करके ऊपर नीचे कर दे सकते हैं, just by thinking that this is a product of 5 terms and the नीचे जो factorial है, that is basically involving 6 factorial, and we use the concept, that the concept what we actually use for calculating the short trick for NCR, that is go on continuously multiplying n into n plus 1 into n plus 2 n minus 2 and so on up to until there is, in the numerator part you basically get 4 r terms, in the divider and in the denominator divided by the r factorial. So that is basically a short trick of calculating for the binomial coefficient. So that thing I basically utilized in this particular problem. So if you basically look at the short trick, if you see 5 terms is here and the 6 factorial is given here, that means basically multiply it with n plus 1, and if you multiply with n plus 1, this will become n plus 1 C6. Similarly, this will become n plus 1 C4, and similarly this will become, see, n by 2. From here on, the thing that got into my mind is n plus 1 multiplying with n plus 1, this will be, can it become, that is n plus 1 factorial divided by n factorial into 2 factorial, that will basically become n plus 1 C2. Okay, so I hope this particular thing was clear. Okay, so let us move to the next important type of problem. Okay, next another important problem. Okay, now this will be a very good example just to see like how we basically solve this particular summation of binomial coefficient without the use of differentiation. Now in the next lecture we will talk about the differentiation method, the integration method, in order to get to the results of the summation of binomial coefficients. Okay, so stay tuned for that. But in today's discussion we'll basically end this particular discussion by taking up this particular problem, that is basically C0. In this particular problem you have to calculate for NC0. If nothing is written in the upper suffix, you just remember it as n. Okay, so NC0 plus NC1, so it is multiplied with 3 plus 5 times of NC2, okay, and so on up to 2NC1, 2 times of n plus 1 C NCN, and this particular value is equal to how much? That's what the question is asking. So very straightforward question. Okay, how we solve it? Now what we know, that in order to solve any summation question, we basically summation question are solved by, so if this is a summation question, we basically solve it by summing the general term. So if we look at the general term, what is the general term? So if you see that r is equal to 0 up to n, it is going, and if I look at the general term is given like this, that is 2r plus 1 into NCR. Okay, so if you see, if you put the value of r is equal to 1, this will become 3 times of NC1, and if you put the r is equal to 2, this will be 5 times of NC2. So this is how we basically get to the general term. Okay, so summation of the general term where r varies from 0 to n will basically get to the summation of this particular binomial coefficient expansion. Okay, so from here you can write this binomial expansion as, now this question can be simply solved by using differentiation method, but I'm not using that particular approach. Okay, so this will be r is equal to 0 to n, and this particular thing can be written as, okay, 2 into r times of NCR plus sigma r is equal to 0 up to n NCR. Now this particular result is known very simple to us, and this is nothing but 2 raised to the power n. Okay, and from here this will become 2 into sigma r is equal to 0 up to n. Now in order to cancel this r, because r is a variable term, okay, so in order to this cancel out this particular r, what I can approach is basically I even use the property number 4, that is NCR is equal to n by r into n minus c r minus 1. So if I use this, that means basically multiplying and dividing by n by r, that will become, make it n minus 1 c r minus 1. Okay, and into there is another r over here for with this r, and this r will get cancelled, and this will become 2n times of sigma r is equal to, so since r is equal to 0 will imply nothing, because we haven't studied binomial when the lower suffix is basically negative. We haven't studied, because the definition is defined in such a fashion that lower suffix is greater than or equal to 0, and n should be a positive integer. Okay, and r should also be positive integer. Okay, so from here this will basically become r is equal to 1 up to n minus 1. Okay, instead of n it will become n minus 1. So if you put or you can do this particular also by like putting n only over here. Okay, sorry, not n minus 1, you will go up to n only. Okay, that's my mistake. Okay, so from this you will get this as n minus 1 c r minus 1, and this particular term plus 2 to the power n. Okay, now this particular term is nothing but, if you look this n minus 1 c 1, so if you put there is 1, this will become 0. Similarly n minus 1 c 1 and so on up to n minus 1. So in place of n you have to put n minus 1 only. Okay, not no mistake, that's thing correct only. Sorry, there is a minus 1 term over inward. Okay, so this is n only. Okay, that is n minus 1. Okay, so from here this will nothing but the 2 to the power n minus 1. Okay, so this will become n into 2 to the 2 into 2 to the power n minus 1 will become n into 2 to the power n plus 2 to the power n, and this will become 2 to the power n into n plus 1. So this is the result of the sum of this particular number. The sum of this particular binomial coefficient, which is given in the particular fashion, that is sigma 2r plus 1 NCR is equal to 2 to the power n into n plus 1, 2 to the power n into n plus 1. So this is a very simple result, and you must remember, you can remember this particular result, or this will take hardly 1 or 2 minutes to derive it. Okay, so 2 to the power n into n plus 1. In the coming lectures, okay, we'll basically use these particular concepts to solve other difficult types of series. Okay, so stay tuned for that. And so this was it all for the properties of binomial.